All right, so let's do a little more trig. And we're sticking with right triangles. We had right triangles before. They probably could have thought of a better title for this, maybe. But it's all right. Yep. All right. The first one we're going to do is kind of what we just finished doing. All right. Let me draw. Actually, I'm not even going to draw anything just yet. Here's what they say. They start right with an example. They don't even teach you anything brand new. They just start with an example. And here's what we're going to do. We're going to use a calculator for some of this stuff. So make sure that you always have your calculator with you. All right. And make sure you know how to use the calculator to do sine, cosine, tangent, and all that good stuff. All right. So here's what they ask you to find. So there's three parts to this, A, B, and C. So the first one says find the cosine of 30 degrees. Now, you could put it into a calculator, I guess. But what if they wanted an exact answer? Because sometimes they'll do that. They did that on last homework, didn't they? On some of those, they wanted an exact answer. What do they mean by an exact answer? They just want you to get it right? Well, not really. Because if your answer has a square root in it, okay, they don't want you to put that into a calculator and get some decimal approximation. All right, when it says what? An exact answer. All right? Everybody with me on that? So that means you have to write it with a square root if your answer has a square root in it. So let's find the cosine of 30. Well, what we can do is we can draw a little 30, 60, 90 triangle, can't we? Just like what we did on that last homework we went over. So let's do that. Here's a 30, 60, 90 triangle. That's my short side, so that's my 30 right there. Everybody with me? So I want to find the cosine of 30 degrees. Well, what did we do first? We made something equal to something to make it a little easier for us. What did we do? We made the hypotenuse equal to what? 1. Good. Do you remember what the short side was? This is where it's very helpful to memorize those numbers. Do you remember what the short side was? No? How about a half? How do you know it's a half? Because the short side is half the hypotenuse, right? The hypotenuse is 1. What's half of 1? It's a half. This is the long side. How do you find the long side? Well, it's the square root of 3 times the short side. So what's the square root of 3 times a half? Square root of 3 over 2. That's half of the square root of 3. Everybody with me? All right, so now the question is, find the cosine of 30 degrees. Well, what's the cosine? It's the adjacent over the hypotenuse. So the adjacent is which one? Which one's the adjacent side? Is it the 1? Is it the square root of 3 over 2? Is it the half? Which one is the adjacent side to this 30-degree angle? Square root of 3 over 2. So this is going to be what? The square root of 3 over 2 over the hypotenuse. That's your adjacent. Over your hypotenuse. And you really probably didn't even have to write it over 1. You probably already knew this over 1 is just this. So what is it? It's the square root of 3 over 2. Everybody got that? All right. Let me bring out that calculator. Sometimes they will ask you to write it as a decimal, especially if you don't have a 45, a 30, or a 60. You're not going to be able to get the answer. Let me do this first. Let's put this in degrees. Enter. There we go. Let's clear it. Okay. So let's put the cosine of 30 in there. So I'm going to hit cosine first. Then I'm going to hit 30. I like to close the parentheses, and you hit that, and there you go. If you wanted to, if they do not say to give an exact answer, you could just put it into a calculator. All right. So if they did not say to give an exact answer, you probably didn't have to do all this stuff. All right. You could have just thrown it into a calculator, and what would you get? 4 decimal places, 0.8660, because that 4 or that 2 does not round that 0 up. So put it there. And you're like, well, Mr. Hamrick, that 0 doesn't really matter. It doesn't mean anything. It absolutely does mean something, okay? It just means that the number to the right of the 6 is not another number, okay? It means it's a 0. So that's rounded to the 4th decimal place. All right? Everybody good with that? So you could write that if it did not say to give an exact answer. So you could use a calculator. Now, these other ones that we're going to do right here, you really can't draw a triangle and do all that stuff that we did with a 30, 60, 90 and a 45, 45, 90 because they aren't 45 or 30 or 60, okay? So this is part B. This is very easy because all you do is plug it into a calculator. It says find the tangent of 72 degrees. All right? So you come over here and what do? Just hit tangent, 72, and then enter. Boom, there it is. Round it to 4 decimal places. So it's 3.077. It's another 7, right? Because that 8 rounds that 6 up to a 7.
So, anytime it's like tangent, just have to make a number to the calculator.
If it doesn't say to make an exact value. You can't figure out what the exact, at this, I don't know if anybody can tell you the truth. There may be a way to do it. I can't think of it off the top of my head. But really, this is your answer. This is really, as far as you're concerned, it's the only way to get an answer for that is to use your calculator. All right? And then C, this is the sine. Now this one definitely need a calculator, 26.2 degrees. But it's super easy. You just use a calculator, right? So it's the sine of 26.2 degrees, and you get that number right there. I really shouldn't put equals. I should put a squiggly equal because it's not exact. Okay, it's approximately. If you put an equal sign, I'm not going to mark it wrong. And like I did right there, I forgot to put approximately, but it's probably best practice to put approximately equal to. 4, 4, 1, 5. And we stop at 5, right? Because that 0 does not round that 5 up. All right, so that is the sine of 26.2 degrees. Does that make sense? All right. Now, let's do something. That was all leading up to what we're going to do now. Okay, that was not that big of a deal kind of stuff. So let's do this. Let's draw a triangle. But it's not going to be a 30, 60, 90. It's not going to be a 45, 45, 90. It's going to have a weird angle in there. And that's why we need our calculator. I mean, you need it. Now, I don't know if they do it anymore, but it used to be, back before everybody had their own little calculators, they would have a chart. They'd have page after page of charts, and they would have 72. And you go down, they'd have a sine, cosine, tangent, and you'd run your finger down the tangent column, and you look to see 72, and where they come together, they would give you a decimal. And they almost always had it rounded to 4 decimal places. That's the old way to do it before people had calculators. That was just before my day. Okay, I came out of high school. I don't think I had a scientific calculator in high school. I got one before I went to college, and it was like my big Christmas present. And you think, wow, your parents, give you a scientific calculator that costs like $10. Well, back then it didn't cost $10. It was like $80, $90, close to $100. And that was back in '83 when $100 was a lot more than it is today. So it was an expensive gift for me. And it was right before I went to college. I was going to be a math major, so my dad figured I needed a good calculator. And he got me a real nice calculator. It wasn't even a graphing calculator. It was a scientific calculator. Anyway, it used to be you have these charts, but now you got these calculators. It makes things easy. So let's list this thing, ABC. And then this side is 8. And this is 72 degrees right here. There's that 72 again. All right. And the problem says, now this is kind of weird, it says solve the triangle. How in the world do you solve a triangle? What do you think? What do you think you're going to do? Solve for everything that's missing. That's correct. Solve for everything that's missing. So angle A is missing. Don't know that. We can find that super easy though. And then this side right here, what do you want to call this side? Since this is angle C, a lot of times we'll make that side C. Does that make sense? Since this is angle B, what do you want to call this side right here? Call it side B. And we make them lowercase. This would technically be what side right here? That 8. It would be A, side A. So what do we want to find? We got, how many things do we got to solve for? One angle and two sides. All right, so let's solve for angle A first. That's super easy. Don't have to do any trig to find angle A. 190? Now, don't give me an answer. Just tell me what to do. Do you? You add them? Yeah, but why do that? Why go 180 minus 90 when you know it's going to be a 90 anyway? So look, these two angles, okay, we've mentioned this on several occasions. These two angles right here always add up to what? To 90 in a right triangle, because you already got a 90 there, don't you? So why bother going 180 minus 90 minus 72? That's an extra step you don't have to do. So really, just do what? Just go 90 minus 72, and that's 18. And it's an angle, so it's in degrees. So this angle right here is 18 degrees. All right, so we're a third of the way done. Didn't have to do any trig, but now we're going to have to do some trig. Because look, I only have one side. I can't even do Pythagorean theorem, can I? Because I only got one side. I need at least two sides to do Pythagorean theorem. It doesn't matter which one we solve first. Let's do B. Okay, so solve for B. I could use this angle 18 if I wanted to, or I could use this angle 72 if I wanted to. I used the 72 because that was the original one they gave me, but it doesn't matter because this is exactly 18. I could use this angle as well. Okay, but let's use this one up top, the 72. How would I solve for B? If I'm using the 72, what is side B compared to this angle right here? Is it opposite, hypotenuse, adjacent? What is it? It's opposite. That's right. Okay, it's opposite. So that's my unknown. What side do I actually know? What side did they give me that I actually know? They gave me this 8, right? All right, so this I've got opposite, and what would this be? This would be adjacent, wouldn't it? So what trig function do I use with opposite and adjacent? Tangent, very good. So let's do it. The tangent of what? Which angle was I dealing with? I was dealing with the 72, wasn't I? Because this is opposite 72, this is adjacent to 72. So I'm taking the tangent of what? 72. And that's equal to the opposite over the adjacent. Which side is opposite? It's B. Over the adjacent, which is 8. And now I just have to do a little bit of math. It's not much, just a little bit, and solve for B. What's my step? I want to get B by itself. Multiply by what? Well, I want the B to stay there. I don't want to move the B. Yeah, I want to get rid of the 8, don't I? So how do I get rid of it? I multiply it. Why? Because it was being divided. So I multiply this by 8, multiply that by 8. What do I have to do to the other side? Multiply the other side by 8, correct? You can just put it right next to that tangent, okay? Put it to the left of it. Don't put it over here to the right. Put it to the left. If you just put an 8 and then tangent, that means 8 times that tangent number, okay? The 8's cancel. So now what do? I just plug that into a calculator. Now this time, I'm actually solving for a length, so we're not going to go 4 decimal places. We're just going to go 1 decimal place, okay? And I probably should have put a squiggly because it's not exactly. So did you try it on your calculator? You said it. 24 what? 0.6 is what I put. Is that what you got? Yep. This was in centimeters. I failed to mention that. So this B is in centimeters. Okay? So there's 2 of the 3 things I got to find. Guess I could have put it in the calculator on here, couldn't I? Yeah, let's do it. All right. So how do I put it into a calculator like this? I put exactly the way it looks. So 8 tangent 72, and then hit that. There it is, 24.62. The 2 does not round the 6 up. That's why I just kept it 6. Everybody good with that? Yeah, it's not too bad. What's the last thing we got to solve? C. Solve for C. Now look, I found B, but B is an approximation, isn't it? So technically, you could do Pythagorean theorem, couldn't you? You could go this squared plus this squared equals this squared. But since this is an approximation, I really don't want to square an approximation, all right? So let's use a trig function. Bell's going to ring any second. Just hang on for a minute till we finish this, okay? So let's use that 72 again. And let's not use the 24.6. Why? Because that's an approximate number, okay? Let's use the stuff they gave us originally. So let's use the 8. So what do I got? I got adjacent and I got hypotenuse, correct? So which trig function uses adjacent and hypotenuse? The cosine. So we're going to write the cosine of 72 equals the adjacent, which is 8, over the hypotenuse, which is C. Now the math is a little bit, just a little bit, tougher than the one we just did, right? Look where C is. It's on the bottom, isn't it? Don't want it on the bottom. Where do I want the C? So this time I do want to put the C on the other side. So watch what I'm going to do. I'm going to multiply this by C. I'm going to multiply this by C. I'll just put it like this. Okay? Everybody see that? But now I got to get rid of the cosine of 72. How do I get rid of the cosine of 72? I divide it. So what do I have? I've got 8 over the cosine of 72. Let's put that in the calculator. Here we go. 8 divided by the cosine of 72, and you get 25 point, we'll round it to one decimal place, 0.9. So approximately 25.9, and this is in centimeters, so we put centimeters, and then we're good to go. All right, well, I didn't get near as far as I wanted. We took too long with the homework, but that's okay. I didn't even write down the assignments. Let me look in the lesson plan for the assignments. Yeah, it was A and B. That was good. So I'll teach B tomorrow. All right, so it's 1 to 15. All right, so it's section, what is it, 12-2 A, and then we're doing 1 to 15. There it is, right there. All right, enjoy it.